Myself, Dr. Ruben, working as Associate Professor and Head Department of Civil Engineering, VFSTR, Guntur, Andhra Pradesh. In this section, we are going to learn some of the basic concepts of important subject in engineering, that is fluid mechanics, and also open channel hydraulics. Now, what actually the course objectives? So it deals with the basic principles, the fundamental concepts and theories of a fluid mechanics. Not only that, we able to familiarize the behavior of the fluids at rest or as well as in motion. Not only that, this course also imparts knowledge on the fluid statics, kinematics and dynamic aspects of fluids, which are very important branches of fluid mechanics. Now coming to the outline of this subject, now this subject has been divided into 5 units, where unit 1 deals with the fluids and its properties and pressure measurement and buoyancy and etc. Now unit 2 deals with the kinematics of fluid flow, and unit 3 laminar flow will be introduced, and unit 4 the minor and major losses in pipes will be taught, and finally main emphasis on open channel hydraulics. Now, what are the outcomes you are going to get? So that is mentioned in this. So in this outcomes of the first unit are, you are going to get the important concepts of properties of fluids, viscosity, density, etc. And from unit 2, yes, we are going to apply the concepts in fluid flowing pipes and vessels. Not only that, various kinds of pressure measuring instruments will be taught, so that you are going to get different properties by using these equipments. Now the introduction or basic introduction regarding the important concepts of fluid, like continuity equation, Bernoulli's equation will be taught, and analysis of open channels for irrigation purpose. As now we construct channels for irrigation purpose, so the analysis will be done. 1. The topic or title of the unit 1, ideal and real fluid. The outline of unit 1 includes finding or knowing the basic properties and various types of fluids, and how to measure a fluid when it is flowing in the pipe system and its devices, the basic concept of Pascal's law and forces on surface, maybe it is a straight or inclined or curved, and also another important concept is buoyancy and metacentric height, and submerged and floating bodies. Now conditions of flotation also will be explained in the slide. Now coming to the basics of the fluid mechanics, it is the branch of science which deals with the behavior of the fluids, maybe liquids or gases at rest as well as in motion. So the fluid mechanics has been divided, which I already told you, into 3 parts, that is fluid statics, fluid kinematics and fluid dynamics. So in the name itself, static means anything that is in rest. So here the study of fluids at rest is called fluid statics. Now what is fluid? The opposite of statics is dynamics. So let me also explain the fluid dynamics. So anything that is in motion, like the study of fluids in motion, where pressure forces are considered, like when the fluid is flowing in a pipe, it is under motion. The example of static is when the fluid is in the tank, that is also another example. For example, every house has one tank. The water that is in the tank is always in static. When you open the fluid starts flowing the pipe, then Then another important branch is fluid kinematics, where the study of fluids in motion where pressure forces are not considered. So different types of properties are there, but if pressure forces are not considered and analyzed, that type of subject is fluid kinematics. Now, in this slide, there are four important properties of fluids. One is density, mass density, in the bracket or rho. Another number two is specific weight or weight density, which is denoted by small w. And another property is specific gravity, or it is denoted by capital S, and viscosity is denoted by Greek letter mu. So in this coming session, these four important properties will be explained in detail, starting with the density. What is density or mass density? It is defined as the ratio of mass of fluid to its volume. Yeah, or mathematically, the mass of a fluid, mass means always we represented kgs, and divided by volume of the fluid. Generally volume is we defined with respect to cubic meter. So density is the mass per volume, that is kg per cubic meter. So for example, if I ask you what is the density of water, so density of water is nothing but 1000 kg per cubic meter, or we may also say 1000 liters per cubic meter. Now, is the density same for liquid or gases? This explains the next two lines. For liquids, the mass density may be considered as constant. It is constant. Whether you go to foreign, it is 1000 kg per meter. But for gases, it is represented by rho gases, generally changes with variation of pressure and temperature. As pressure varies, the density changes, and as temperature, it depends on temperature. Important properties of fluid is a specific weight, or simply weight density small w. The specific weight of a fluid is defined as the ratio between the weight of a fluid expressed in newtons to its volume. Mathematically, it is written as weight of fluid divided by the volume of the fluid cubic meter. Now, the specific weight also can be written as mass of a fluid into acceleration due to gravity. So here we can able to observe the weight of fluid. We can also write our the mass into acceleration, which follows the Newton's law, that is F is equal to mv. So, and divided by volume of the fluid. So generally, already in the previous first property, mass by fluid divided by volume of the fluid is expressed as the density. The same thing is notation is given as density into G. The specific weight can be also written as the density of the particular fluid into acceleration due to gravity. So this is very important equation which we are going to use in various problems to convert any density into specific weight, or specific weight into density of the particular liquid. So as was earlier in the first unit, how we found the density of water, here also the specific weight of water is nothing but the density of the water, already explained, 1000 into the acceleration of the gravity, 9.81. So the specific weight of water is given as 9810 Newton per cubic meter, or simply 9.8 kilonewton per cubic. Now, the another property is specific gravity. So it is defined as the ratio of density of a fluid to the density of a standard fluid. Mathematically, the standard fluid we generally treat for liquids as water, and the density of fluid is where we are interested for the particular type of liquid. So the same thing mentioned for liquid, that standard fluid is water. If at all the fluid is of gas, we consider the standard fluid is air. So the specific gravity of water, S water, is equal to 1000. The general density of water is 1000 divided by the standard fluid. Standard fluid is also water. So 1000 by 1000, how much it is? It is 1. So specific gravity is always 1. Similarly, if you take the mercury, which is a semi-solid, which is the high weight or the thickest fluid, the specific gravity of the fluid is 13.6. So the one of the unique feature of the specific gravity is it is a dimensionless quantity, means there is no dimensions. For example, density of liquid divided by density, so both are observed, both cancel, and there is no, that is one. Another important note we must know is, if a particular specific gravity of fluid is known, then the density of the fluid will be equal to the specific gravity of the fluid multiplied by the density of water. That is one of the uniqueness of this specific gravity. For example, if I know the specific gravity, which already I explained in the previous, it is 30. So now what is the density of the mercury? It is nothing but the multiplication of the specific gravity into the standard fluid, that is 1000. So 13,600 kg per cubic meter is the density. So likewise, we can work out for any number of liquids and fluids. So there is a problem here which we are going to learn is, so in this problem, so calculate the density, specific weight of 1 liter of petrol of specific gravity 0.7. So the previous slides have been telling you the different properties of water. Okay. So problem may be given, maybe if it is a petrol, please calculate what is density, specific weight and weight. So first of all, what is the given? Yes, the volume is given as 1 liter, that is 1 into 1000 centimeter cube, or we know already 1 cubic meter is called 1000 liters, or it is converted to 0.001 cubic meter. Please, yes, this is the first problem I am instructing everyone. Please use always SI units. Do not use CSI, CGS or MK system. So in SI units, international system also, everything should be in meter square, cubic meter. So let convert volume of anything into cubic meter. Here the same thing has been done. Volume converted into cubic meter. Now the given thing is specific gravity is given as 0.9. You may be thinking, where are we? Yes, already I told, specific gravity does not have any value. So the specific gravity is 0.9. So they asked us to calculate the density of the petrol. Yes, so density rho. So as previously told, density of petrol is nothing but the multiplication of the specific gravity into the density of standard fluid or liquid, here 1000. So what is the density of the petrol? Now we are going to get, it is 0.7 into 1000. See, 700 kg per cubic meter. The density of petrol is 700, which is very less compared to the water. Now coming to specific weight, so we know the specific weight is nothing but the density in multiplied acceleration due to gravity. So we know the density of fluid is 700 and 9.81. So the total specific weight is 6867 Newton per cube. That is the